Spring has arrived in Munich, the flowers are blooming, the sun is starting to shine, but the hottest news, they're coming from MVTec because HALCON 26.05 is here. My name is Markus Major, I'm part of MVTec's marketing team, and as many times before, it's my pleasure to guide you through this webinar. Today, you will receive all information regarding our brand new features, how to implement them, and also how to benefit from them. And before we start, let me give you some quick notes on our setup today. So first of all, we are doing a survey at the end of the session. We kindly ask you to fill it in. Also, if you have questions, you can write them in the GoToWebinar chat because we're doing a Q&A session afterwards. Also, at the end, you will receive a recording and a handout of today's webinar. That's it for now. That's it from my side. And now let's move the spotlight to our speakers. Please welcome on stage Application Engineer Agnes Weinhuber and also Jan Gärtner, Product Manager HALCON. Join me on stage. Welcome. How are you doing?
Hi, fine, thanks.
Is this your first webinar, correct?
Yes, it is.
What are your expectations? Are you excited? Are you nervous?
Yes, of course, I'm a little bit nervous and very excited and happy to be able to present the new features with Jan. Wonderful.
Yeah, I think it's many interesting topics today we are covering. And Jan, how do you like, as an old rabbit, as we say in Germany, if you're already doing this for a long time, our brand new streaming studio? People can't see, but this is brand new. How do you like it?
It's awesome. It looks way more professional now. Really great, but I think for our audience it basically looks the same, unfortunately, but I can tell you the experience here is, great.
Yeah, cheers to the whole team here at MVTec who made this possible. It's really awesome. You see, I don't even want to leave the stage, but I have to, so enjoy the webinar. Thank you very much, guys, and see you later for the Q&A.
Thank you, Markus.
Thanks.
Yeah, also warm welcome from my side to our HALCON 26.05 new feature webinar. In the next 40 minutes, you will see the latest HALCON features, how you can use them, and how you can benefit in your actual applications from these new features. So let's have a look on the agenda of today. So today we will start with our deep learning topics. You will learn how you can increase the throughput for your deep learning application and make it more robust. And then we will go over to our rule-based technologies, because we believe the combination of deep learning and rule-based technologies has the biggest benefit for machine vision. And during the webinar, Agnes and I will hand over very often, so sometimes we show high-level slides so you get the basic overview about what the technology is doing, and then later on you get a technical insight how you can actually use this technology for your application. And with that, let's directly start with our first section for today, deep learning. And here we want to speak about advanced AI object detection. Object detection is used in many applications, for example, detect products, parts, defects, or items like the pills that you can see here on this image. In these applications, two things are really important. The first thing is detection quality, and the second thing is runtime performance. And luckily, we can say with this release, we have improved both the detection performance and the inference speed. So as you can see here on this table, we could, on average, speed up our object detection inference time by ×5, and at the same time, we could increase the mean average precision here. That's great news, and for this release, we are offering this new technology now for axis-aligned bounding boxes, so the boxes you can see here in the back. With the next release, we will also offer it for orientated bounding boxes, so also known for HALCON users as Rectangle 2. This model is also available in 3 sizes, small, medium, and large, but about that, Agnes will tell you more now.
Yes, thank you, Jan. On the next slide, you can see some benchmarks we brought to visualize our improvements. First, I want to describe how to read this visualization. We are once again providing the model small, marked in orange here, medium, marked in yellow, and large, marked in blue. The bars for the old models are hereby marked with stripes. And on this slide, you can see how much our inference performance for CPU devices with OpenVINO improved, shown in milliseconds. On the left, we can see that we already performed fast on CPU bfloat 16 with our old models. With our new models, we could reduce the inference time around 4 times in average. Looking at the small model, we are almost 6 times faster now. Even more improvement you can see on the right, showing the CPU float 32 performance. The runtime is reduced in comparison to the old models in average by 16 times. Here even the large model improved almost 6 times. And looking at the inference performance for our GPU devices on TensorRT, we can also see the improvements in runtime. For GPU int 8 devices, shown on the left side, we improved 2.5 times in average, and for GPU float 32 devices, our average improvement is almost at 6 times. What is great to see, also for the CPU devices on the previous slide, is that even our large models are faster than our old models, old small ones. And what exactly does this all mean for your applications? You can choose between different pre-trained models and select the one that best fits your application. If the primary goal is speed and the objects allow for it, you can choose a small model. If higher accuracy is required and there is sufficient capacity for a larger model, also in terms of runtime, you can choose a large model. Especially for float 32 devices applications, there's still significant improvement to be gained. So our key message is always choose the right model and precision to get the best performance for your application. Talking about applications, we also brought a slide to show you that we are providing more stable and reliable detection performance across a wide range of challenging applications. Here we visualized some data showing the improved mean average precision. In comparison to our old model, old object detection with a large network shown in the striped blue bars, you can see the performance of our new advanced object detection networks. Looking at the comparison between the old large and the new small network, which is marked orange here, we can already show improvements. But the comparison of the old large one with our new large object detection shows that we can outstand the latest detection performance. For example, looking at both of the food industry datasets, we did increase by around 6%. And for all this, we have a new standard example for you. Can you click to it? Thank you. To learn more about it and about the advanced models, you can look at the standard example, which is called DL Advanced Detection Workflow Now. It is replaced, the old example has been replaced with this new one. And in this example, the overall workflow for object detection using axis-aligned bounding boxes is demonstrated.
Thanks, Agnes. So the key message here for our customers is that you can now, with the new object detection, increase the throughput or, on the other side, save money by using cheaper hardware because the new models have lower hardware requirements here. And not only our new object detection model is a way to make your application more robust and more accurate. Another technology that really benefits here is the advanced data augmentation that we are now offering with HALCON. In deep learning, the quality of the data set is really crucial. And data augmentation basically helps you to create a more diverse data set for your training. The goal is here to make your model more robust during training. And you do this by adding various augmentations, so that by modifying your existing images with various filters and algorithms. So what we did here is, on the one side, we are offering a new augmentation pipeline, and we also focused here on usability. So the new pipeline you can configure by operators. In the past, it had been procedure-based, and this has really many benefits for our users, because procedures are sometimes difficult to export when you're using HDevelop. The code doesn't look that clean. With operator-based pipeline definitions, it's way cleaner and easier to use. Before we have a look in how you can configure an augmentation pipeline, let me give you one more example. This new technology is basically in the first run available for object detection, and here we can see, for example, one input image, and then during the pipeline we are adding various augmentations. So in general, augmentations had been available in HALCON before, but one thing that is new here as well is that you can combine multiple augmentations together to get an even more diverse training dataset and an even more robust solution. But now let's have a look how we can use the new augmentation pipeline.
Yes, I will guide you through the enhanced workflow and how to increase the count of images. In the first step, you create different augmentations. This can be defining transformation for a random crop, flip an image, or also pre-processing like normalization or resize. And for each of those augmentations, you can see now you have to choose a separate operator now. With those defined handles, you are creating pipelines in the second step. You create a pipeline of transformations for the training of the deep learning model with the augmentations and pre-processing. And also a pipeline for the inference, which just consists of the pre-processing steps you need for your deep learning application. In the third step, you assign the created pipelines with the different splits, train, test, and validation to your dataset. Then the training is used like it was previous, but you don't need the pre-processed DL dataset here anymore, because we assigned the pipeline to the DL dataset before. And those pipelines are used for the batch image augmentation during training. In the last step, we are generating a DL sample of the image. Then we are using the transform DL sample batch operator to get the DL sample transformed and use this in our apply DL model operator in the last step. So the augmentation workflow in the past, based on procedures, was a little complex to export. With this new pipeline workflow, now based on operators, it's handier and user-friendly, and we provide a more modern and flexible workflow. So the augmentation is performed on the fly, is highly configurable, and you can apply multiple augmentations per image. And also for this new data augmentation workflow, we designed a new standard example for you. It's called DL Transform Pipeline HDEF. Try it out. And to see the pipeline workflow in use, you can also have a look at the previous mentioned standard example.
Thanks, Agnes. So with this new data augmentation, you get an easier to configure augmentation pipeline and at the end, more robust deep learning results. Now let's go over from our deep learning news over to our rule-based machine vision technologies. And here, first of all, I want to talk with you about automatic contour optimization. So shape matching is a very powerful machine vision technology, a rule-based technology, and it's used for many applications. But you might make this experience here in real-world applications. Sometimes configuring a shape matching template could be really difficult. The reason here is reflections, scratches on the surface, and maybe changing illumination. All these effects can create unwanted edges in your matching template, and those noisy edges on the one side will increase the inference time and also make your model less robust. So you might make the same experience as this guy here on the right on the slide, that it's really frustrating to configure the template or the template creation process. Our solution for this now is the automatic contour optimization. Here we brought you another example. So a similar looking ring, once again metallic surface, difficult reflections, uneven surface, and when you're creating a template based on this surface, you might well see something like that, a noisy model. And a noisy model, as said, is not good for your application. With our automatic contour optimization, you have basically a new magic tool to remove all these noisy model contours and get a cleaned model at the end. And a cleaned model leads to faster inference and also more robust solutions. Let's have a look on the workflow. The workflow in general is really similar to the workflow that you already know from our recently released automatic parameter estimation. So what we need here in general is a labeled template image. So the image contains the template region that you want to detect later on. You can see it here on the top left. And you provide various sample images. So this could be like around 3 to 10 images. And also these images must be labeled with the object instances. You provide all this information to our new algorithm, and at the end you get the cleaned model, and the cleaned model can be used by your shape matching model for the actual application. And now let's have a look into the code example.
Yeah, the workflow for shape-based matching largely remains unchanged, but enhanced. First, we are generating a generic shape model, and in the second step, you're adding multiple representative training samples as array to support the automatic contour optimization algorithm contour pruning. In the next two steps, you are choosing the sample-based training as the training method, and the training parameters are set. Here you now can adjust the contour pruning threshold parameter to define how much the model should be pruned. A higher threshold in this case means less contours. This value and the selection of the samples must be tuned depending on your application requirements. And in the fourth step, the generic shape model is trained, and you can query your new contours to check on them. Finally, the online application step is applied to locate the shape model within the search images. And also for this, we do have a new standard example you can have a look at. It's called Train Generic Shape Model Contour Pruning Workflow HDEF. With this new automatic contour optimization algorithm, significant improvements can be introduced for shape-based matching. It enhances speed, robustness, accuracy by cleaning up a matching model's unstable contours. In difficult cases, where manual editing was previously required, the new approach now provides an effective solution to determine optimal contours that stay stable in the samples. So our key message for this new feature is learn from the representative samples instead of tuning your parameters. And the desperate guy Jan showed us before now hopefully looks a little bit happier.
We definitely hope that. And staying with our rule-based technologies and edges, we also made another improvement in the field of edge extraction algorithms. So edge extraction, especially subpixel accurate edge extraction, is important for many applications. It's a key technology, and it's used for measurement tasks, PCB inspection, and other quality inspection scenarios where precision is critical. So you can see some examples on this slide. In previous versions, here you can see on the left, sometimes we had problems with the edge extraction. So for sure it worked really good, but there was some room for improvement. So we had some spurious edges here and some unnecessary breakups with our edges suffix operator. With the latest release, we could really improve our edges suffix operator, that it now has less spurious edges and no unnecessary breakups. And this is really crucial for applications where you are needing precise measurement, because all the small edges can affect your measurement tasks. But now with the 26.05, this isn't a problem anymore. And the best part here, you don't have to change your workflow. So the new algorithm is used automatically when you upgrade to HALCON 26.05 and you're using the edges suffix operator. Now, from one rule-based technology, edges and shape matching, we go over to another section, identification. And here, specifically, identification of codes. This release as well, we worked on our data matrix code reader, which is used, for example, in the pharmaceutical industry. And there often we have bottles, curved surfaces, and the codes are printed on the surfaces. And curved surfaces leads to more challenging codes because the code is basically deformed. In our recent release, we have improved our QR code reader to deal better when printed on curved surfaces, and now we did the same for our data matrix code reader. I give you here a little example so to better understand. So in general, what stays the same, we have our QR code on a curved surface. We are finding the QR code, it's the same, but now we have a new rectification algorithm which works way better in rectifying the actual code. And now we can read this code more easily. To use the new feature, you have a few options. In general, the data matrix code readers has 3 modes for the recognition: the standard recognition mode, the enhanced recognition mode, and the maximum recognition mode. When you select maximum recognition, by default, the new feature is turned on, so you're benefiting from the better algorithm here. When you're using the standard or the enhanced mode, which are more focused on speed, this feature is turned off by default. But for sure, as with every code reading feature, you can turn it on and off manually by the operator you see here. So that's about our new code reader rectification for data metrics.
And we also have some great news for you about encoding heuristics for 2D data codes. And since Jan just showed us an example for the pharmacy industry, we now show another field of application. When you're working in logistics or a company which is connected internationally, maybe sometimes you're facing the challenge not to know where the code on a package comes from. But to read the string behind correctly, you always have to know which encoding to use. For example, with the shown data code, is it Latin 1 in the first picture? No, probably not. UTF-8? Neither. Shift GIS? Indeed, now we can read this string. But what happens if we do not know where the codes are coming from? With 26.05, we now have the possibility to use heuristics to guess the right 2D data codes, string encoding. This is easily done by choosing the new value auto, setting the string encoding parameter in the operator set data code 2D param. This removes the need for the users to manually set the value, so to have the knowledge about the encoding to be used to read the codes. And on the next slide, we want to show you a showcase of using auto. For example, you have to work with different encodings, and here we do have 5 different codes. With Latin 1 and with UTF-8, you are not able to read all of them. But with our new value auto, it automatically chooses the right heuristics to read the code, and we can now read all of the 5 codes. And we also brought you some news for barcodes on the next slides. Since EAN13 and UPCA, both defined in ISO IEC 15420 up to HALCON 25.11, the decoded string for both of the barcodes consisted of 13 digits. But EAN13 codes with the leading digit not being a 0 and UPCA codes with an artificial added leading 0 followed by 12 digits of actual data. And this sometimes leads to the misinterpretation of UPCA codes as an EAN13 code. With 26 furthermore, barcodes of type UPCA are also found if the expected code type is set to EAN13 in the operator find barcode, since UPCA is a subset of EAN13. But with 26.05, we now have a new feature for you to avoid those misinterpretations and make it easier on your side. We introduced the new parameter strict EAN13 UPCA, which can be used to enforce a strict distinction between the both barcode types. If the parameter is set to false, the old behavior is preserved, and this is the default setting. And if the parameter is set to true, barcodes of the type UPCA are not treated as a subset of EAN13 barcodes anymore. And the decoded data string consists of 12 digits now. But we are not only reading codes, aren't we, Jan?
Right, we are also reading text. And after speaking about code reading, I'd like to inform you also about our latest improvement for our deep OCR, the whitespace support. So in the past, actually whitespaces hadn't been necessary because most of our customers are following the typical workflow here. So they are first using the detection model of our deep OCR to find the actual words within the image. And then later on, they're using the recognition model to read the text in each text box. What's new here? So basically, in recent years, now customers started to use only the recognition because they are actually knowing where the actual text should be. And our recognition model got more robust when the text box was not tightly cropped around the text. And so more customers used the deep OCR like this, and they have experienced a new problem that the white spaces hadn't been detected or couldn't be detected. So with HALCON 26.05, we are now adding whitespace support to our deep OCR recognition model, so no information get lost anymore, as you can see here in the bottom of the slide. This feature is activated by default when you are upgrading to 26.05. When you want to deactivate the whitespace support because you might want to, you don't need this information, you can simply remove the whitespace from the recognition alphabet.
And also from the side of our hardware integration development team, we have some news for you. They are continuously working on new features. The recently released image source operators in 25.05 are being further enhanced from on the way to the full functionality, with new capabilities added in every release. And in this release, configurations can now persist across sessions and machines when using image source operators. Means you can now reload the previously defined camera setup. From an application perspective, this means camera settings such as exposure can be preserved even after a power cycle or system restart. Instead of manual reconfiguration, because the camera is reverting to default settings, reloading of the configuration is possible now. Another advantage is that you can recover a configuration in case your device fails and needs to be replaced with a new hardware of the same model. And we also enable a new deployment scenario, rolling out configurations to multiple machines. This is possible because identifiers can now be stored within the configuration, and by this, identical systems can be set up quickly and consistently. This leads to no need to configure each system individually anymore, and it's ideal for automated rollout in larger installations. And to show you how it looks like in HALCON, we first look at both use cases like power cycle or device replacement. In the light blue box, within the first two steps, you set up your image source operators and configure the camera. Within the third and the fourth step, you're writing the configurations to file with write state string in the control image source operator, and actually writing the state string to file with fwrite string. And after the power cycle or replacement, the steps in the dark blue box are to be done. After loading the string from file to our script again in the fifth step, the previously saved configuration can be reused directly within the sixth step. You're connecting with the replaced or repowered device, and with the connect image source operator, you apply the configuration on the device. So no manual resetup is required. And looking at the new deployment scenario, it looks like this. Configurations can be persisted as part of the entire image source setup, not just for the device itself, also for device, for plugin, and for stream. And here you can see the first steps are similar. Expect to write the whole setup with write config file. After those three steps of writing the configuration to file, you now can multiply the configuration files saved to your PC, for example, and adapt, in this case, the serial number of your devices. And then in the fifth step, roll out this configuration on multiple machines. And what we want to highlight here is that reconnecting now is straightforward and does not require programmatic specification of what to connect to. Yeah, speaking of connections, we also brought you some news about process integration. Our Hilscher CIFX interface for communication with Hilscher cards is now also running on Linux devices. This enables communication with the controller via one of the here shown supported industrial protocols such as Profinet, Ethernet IP, or Modbus, allowing industrial communication to run on Linux as well.
And now we really have learned a lot about our core HALCON library. So new algorithms, new communication plugins, and stuff like that. But with HALCON, you also get development tools to make your development experience smoother and easier. And one tool that we're providing to our customers is the variable inspect that you can use in Visual Studio to actually visualize your variables when you're debugging an HALCON application. So images, regions, and other HALCON objects. With the latest HALCON release, we are offering now the support for Visual Studio 2026. And why do I bring the slide here today? Because I like to inform you that we are discontinuing the support for the 32-bit version. So there's no support for Visual Studio 2019 and older. So if you plan to upgrade to the latest HALCON release, make sure that your development environment is also updated accordingly. And then there's another hot topic at MVTec. We are at the moment really investing a lot into our preview of the new development environment HDevelop Evo together with our new HALCON script engine. So both are the successors of HDevelop and the HDev engine that we are offering at the moment. So first of all, let's have a look into the HALCON script engine. So with our recent release, we added the support for C++, and now with this release, we are adding the support for .NET. So you can integrate the HALCON script engine, the preview, still it's preview, into your .NET application. And this is especially important because most of our customers are .NET users. So they are now having the chance to integrate the HALCON script engine and try it out to get a feeling what the future of HALCON script integration will look like. And I can tell you it's not that difficult because we are really paying attention that the migration from the HDev engine to the HALCON script engine is as easy as possible. When we are looking on the packages that you need to embed the HALCON script engine, here first of all I brought the packages that you're most likely using today for the HDev engine. So for sure you need the HALCON runtime, you need the Nugget package MVTec HALCON.NET, and you need the MVTec HDev engine .NET package. The only replacement here is that we are now offering another package additionally, the HScript engine.NET, if you want to use the new HALCON script engine. And for sure we also have this additional plugin, HALCON.NET Windows, and this plugin stays available as it is. But now let's have a look how the actual API for the integration does look like.
Yeah, in practice, it looks like it's shown here. To keep it as easy as possible to use for the customers, we kept the .NET API workflow as similar as possible to the previous provided C++ API. Also, the HALCON script engine is kept as similar as possible to the HDev engine. And another advantage we want to highlight here and show with this slide is that the inline parameters can now be passed directly in a procedure call. It is no longer needed to set the additional operator to set, as in this case, the image as an input parameter. This makes handling both input and output parameters much clearer and more intuitive. But this is not all of the improvements Jan and I want to show you around HDevelop Evo. I have 3 further developments on the next 3 slides to show you. The HALCON script engine and HDevelop Evo now support entering a procedure and file documentation. The descriptions are hereby started with entering the single quote 3 times. For the whole file, when entering the quotes before the use procedures. To describe one parameter or the procedure, insert the quotes inside the procedure. What hereby comes in really useful is that code snippets are provided to insert the documentation, and auto-completion assists entering the available attributes by stepping through the placeholders using the tab key. And mouse over shows you the documentation and makes it simple to get information about your procedures. And some further information. The documentations may also help you entering the right values during auto-completion, and also the APIs allow to assess these attributes and its values. And one gets informed about through warnings about wrong entries. And with the HDev converter exe, you now can convert HDevelop scripts. You now can convert the HDevelop scripts which have the procedure documentation into the new format. And then there's something new about our AI prompt too. The support for multimodal language models has been improved with the introduction of visual prompting. To do so in HDevelop Evo, we have multiple options. We can use images from our workspace by drag and drop them to the AI chat. Images can be attached to the prompt by selecting the appropriate elements in the attachment options via the paperclip button. And you can add image type variables from the iconic variable view directly to your prompt. And also what we are showing here in the slide, you can now attach the content of the graphics window to the prompt. The visual prompting can help you looking for the next steps in your application, for example. And what also helps you, we have some further improvements here. The HALCON search agent can now be used to search for an HALCON operator or a standard example. This can be, for example, useful when you're knowing what you want to achieve in the next steps, but you, for example, are not sure how exactly the operator is called to do so.
So, as you see, step by step, we are adding more features to our HDevelop Evo preview and the HALCON script engine, with the final goal for sure to replace HDevelop in the future. But still, it's a preview, try it out and provide us feedback here. And now we are almost at the end of the webinar today. I like to share with you one legacy note here, and I'd like to inform you that we are transitioning the Halo AI Square plugin into a legacy status. The main reason here is that we are seeing a decreasing demand from our customers for this specific plugin, and therefore we are currently do not plan further development activities here. For sure, you can still download the plugin, you can use the plugin, but for new applications, basically we recommend using our alternatives like the OpenVINO or the NVIDIA TensorRT plugin here. And for sure, we are also collaborating with new partners now. So one example here is Qualcomm. Really soon we will release a new Qualcomm plugin for our HALCON library. And we are working together with other partners. You will get more information in the near future. If you have any specific requirement, you can always contact us and tell us what you need. With that, we are at the end of the HALCON part of this webinar, and I really hope you have enjoyed all the information you have seen here and that you have learned how you can increase the throughput with our latest HALCON version, how you can make your application more robust and you have learned how you can more easily create your solution. One short hint at the end, we also have released the new deep learning tool version in March this year. And with this deep learning tool version, we have now the support for the deep OCR alignment training directly in the deep learning tool. So when you're using the deep OCR recognition alignment, so when you have this coarse cropped bounding boxes, this feature is really handy to use. And there are also some other smaller improvements. If you're interested in learning more about, simply check out the release notes. And with that, thank you. We are now having a short survey, as Markus has mentioned in the beginning. We kindly ask you to fill out the survey. It's maybe 5 minutes, maybe a little bit less. And then we see once again in 5 minutes for the actual Q&A session. Thank you.
Thanks.